Here's a problem intended to show you how to deal with negative exponents. So for example, what would it mean to take a number like 2 and raise it to a negative exponent, say negative 3? Before showing you the pattern here, I want to go back to using positive exponents, and I want you to look at 2 to the first versus 2 squared versus 2 to the third power and remind yourself what that means. So if you remember what 2 to the first versus 2 squared and 2 cubed means, I'll start with 2 cubed. 2 cubed means that we're going to take this base here, the number 2, and we're going to multiply it by itself several times, and then the exponent, in this case 3, tells me how many occurrences of the number 2 there's going to be. So since this base is 2, I'm writing the numbers 2 here. This tells me how many to write. I need to write 3 of them. If I do so, I don't know why I keep doing that, we have 3 occurrences of the number 2, and if you multiply that out, 2 times 2 would give you 4, and then multiply by 2 again, you'd finally get 8. So 2 cubed is 8. And if you let me back up a little bit here, 2 squared would be the same thing. We'd be making many 2's in our problem. And since the exponent's a 2, that means we want 2 occurrences of this number. So here's my first occurrence of the number 2. Here's my second occurrence. And if you multiply that together, you get 2 times 2, or 4. And 2 to the first matches that pattern. It says, make a bunch of occurrences of the number 2, but how many do I want? Well, I only want 1, 2 in my problem. So there's nothing to multiply, and you just get 2. So the pattern is that every time your exponent here goes up by 1, if you change this from a 1 to a 2, that puts another copy of a 2 in there, another occurrence, and that makes the answer to the problem twice as big. So we went from 2 to 4 to 8. So if you were to go backwards, for example, if you were to try to explain to somebody the relationship between 2 to the third power and 2 to the second, going backwards, instead of saying that this gets twice as big, since I want to look at what happens going in the reverse direction, you could say if your exponent goes down by 1 from 3 to 2, then your answer gets cut in half. Half of 8 is 4, and half of 4 is 2. So the only way I'm going to be able to argue what a negative exponent means in this problem over here is to go backwards. So when I had 3 occurrences of the number 2, I had 8. When there's 2 occurrences of the number 2, I had 4. When there's 1 occurrence of the number 2, we had 2. So the pattern was, as this exponent goes from 3 to 2 to 1, my answers get cut in half. 8 cut in half is 4. If you cut 4 in half, you get 2. And then finally, we get to this one, which you may not know. What does it mean to take 2 and raise it to a 0 exponent? Well, if we're going to fit this pattern, I once again made my exponent 1 smaller. It fits the pattern, 3, 2, 1, 0. In fact, it just keeps going with that. If I keep subtracting 1, 3, 2, 1, 0, negative 1, negative 2, negative 3, it seems like a meaningful way to define this would be to keep cutting in half as I go from right to left. Half of 8 is 4, half of 4 is 2. So if I'm going to define what 2 to the 0 is, and I want to keep this pattern, I would say half of 2 is 1. So it turns out to define this in a meaningful way, numbers to the 0 power are defined to be 1. It turns out, with only one exception, all numbers to the 0 power are 1. And if you want to continue this pattern then, since I want an exponent of negative 1, then to continue this pattern of cutting in half, half of 8 was 4, half of 4 was 2, half of 2 was 1. If I cut 1 in half, I'd get a half. If I take the number 1/2 and I cut it in half, I get 1/4. And if I take the number 1/4 and I cut it in half, half of 1/4 is 1/8. So this is a meaningful way to define negative exponents. Now when you actually go to do the problem, you don't necessarily have a bunch of examples here, like a chart, to aid you in figuring out what the answer is. So what you end up doing is using an exponent property. So if you go all the way back here to 2 raised to the negative 3, the actual doing the problem isn't necessarily done by understanding the pattern in this chart that I showed you. What you can do is, if you ever have a negative exponent, think of the problem not as 2 raised to the negative 3, that your answer is going to be 2 to the third, because we want to write the answer without a negative exponent. It's just when you do that, when you write it as 2 to the third, instead of 2 to the negative 3, it needs to be into the denominator. So I'm going to go back over here and work these problems. See if I can delete what I had previously done here. And now that we have a negative exponent, I'm going to explain it this way, that if you have 2 to the negative 3, that that's equal to, you can rewrite it as an equivalent value as 2 to the third. It's just when you do that, if you're going to get rid of the negative exponent, you need to put it in the denominator as 2 to the third, and then it leaves a 1 in the numerator. So we'd have 1 over, and then 2 cubed means 2 times 2 times 2. And if you multiply that out as we did before in the video, you'd get 1/8. So we have the answer to two different segments over here. The first question would be, write the expression without negative exponents. So we did that. We changed this problem into this one. We wrote it without a negative exponent, but doing so made it so that we had to put it in the denominator like so. And then it wanted a simplified expression, so I simplified it by just taking 2 and cubing it to get 8. So you see 1/8 there. And then this pattern continues. You keep moving on like this. And I'm going to do a few more. So if I go down to some more practice problems, you can do the same thing here as we did above. So 3 to the minus 3, 3 to the minus 2, and 3 to the minus 1. I will do again. In fact, they're asking for 3 to the 0 as well. Let's work those out. So I'm going to write down 3 to the minus 3. And what I can do then is think of that again as 3 to the positive 3. Always write your answers if the negative wasn't there. But if you're going to get rid of the negative, there's an exponent property that I'll show at the end of the video that says you can write that as 3 to the third power, and then that leaves a 1 in the denominator since there's nothing up there anymore. You wouldn't be correct if you put a 0. And then when you go to simplify, just remember that this means you have 3 occurrences of the number 3. So this tells me how many 3's to make. This is to tell me what number I'm to use. So that would be 3 times 3 is 9, and then 9 times 3 is 27. So when I go to do the problem, I'm going to have two different answers. I have the answer 1 over 3 cubed, and I have the answer 1 over 27. So going back over here, the first thing they want me to do is write this without a negative exponent. So I want to write it as 3 to the third. The rule is we have to put that in the denominator. So I'm going to write 1 divided by 3. Now to get an exponent on the keyboard on your computer, you hold shift and press 6. That gives you a caret key. And then I'm going to do 3 and preview it to show that I did what I was supposed to. I wrote as 3 to the third, but I put the 3 to the third in the denominator. And then since they wanted a simplified expression, I figured out that that's 1 divided by 27. And if you want that in what's called pretty print form, you can preview it and see what I did there. Continuing on, if you have the patience, let's do 3 to the minus 2. And it's going to be using the same technique. I'm going to take 3, raise the negative 2. Again, you start by actually writing the problem without a negative exponent, so I'm going to write it as 3 squared. But when you do that, when you get rid of the negative exponent and you write it as 3 squared, you have to put it in the denominator now, and that leaves a 1 up here. And then the simplified form would be that 3 squared means make 2 occurrences of the number 3. So it's 3 times 3, and then that would be 9. So I have 1/9 as my answer. So this is the simplified expression. This is the expression I got before simplification, just writing the problem without a negative exponent. So going through that, this would be, instead of 3 to the minus 2, I'm going to write it as 3 to the second power, but I need it in the denominator, so I'm going to write 1 divided by 3. Shift 6 gives me a caret. I type in 2, hit preview. Just make sure that your exponent is now positive. You wouldn't want to write that as a negative because the whole idea was to write the answer without a negative. And then we figured out that this would be 1 divided by, and then 3 squared means 3 times 3 or 9. Let's preview that to see that. Now the last one here, 3 to the minus 1, you could think of it as 3 to the first. That's writing it without a negative exponent, but it just turns out 3 to the negative 1 is not 3. For the property to work, if you remember, it has to be in the denominator, so it's 1 divided by 3 to the first, so it turns out that's just 1/3. In fact, there really isn't much to simplify here. The simplified form would just be 1/3. When you preview it, you get the same thing just without the little exponent of 1 there. If you remember right, I said earlier in the video that any number to the 0 power is 1. There's one exception. Turns out if you take 0 and raise to the 0 power, that's undefined, but you won't run into that in this problem. So 3 to the 0 power turns out to be the number 1 by definition, and not just by definition, but we needed, it is definition, but we need to define it in a way that fits this pattern that I talked about earlier in the video. And then 3 to the first power just means multiply, don't do anything with the number 3. 3 squared means do something with the number 3, multiply it by itself, but make sure that you have 2 occurrences of the number 3. So literally that means 3 times 3, but we'll write that as 9, of course. And then 3 to the third power means multiply 3 by itself several times. Make sure that in your final product here that there's 3 occurrences of the number 3. And earlier in the video I showed that that's 27. 3 times 3 is 9, and then multiply by 3 again, you get 27. No need to preview these, but if you want, you can. Just to show that as you move to the right, every time your exponent goes up by 1, the answer to the problem can be obtained by multiplying by 3. This number times 3 is this one. This number times 3 is this one. 1/3 times 3 is 1. 1 times 3 is 3. 3 times 3 is 9. And 3 times 9 is 27. So the bottom part of the worksheet is exactly the same, except you're going to be using a base of 10 rather than a base of 3. Now I promised, if you had the patience to stay to the end of the video, that I would show you a way of thinking of this in its general form. So in math we like to give people a general way to do problems. So it's not really saying anything different than we said in the video, it's just using some letters to represent any problem. So for example, if I wanted you to take 3 and raise to the negative 8, say, I told you to write it as 3 to the 8th, but not literally like that. It needs to be in the denominator as 3 to the 8th, and then it leaves a 1 up here. So if I had to communicate to other people mathematically that property, the exponent rule would say this. If you have some number a, and in my example a is 3, and it's raised to a number, but there's a negative number in the exponent, one way to set things up is to write it this way, and then tell people, okay, if you want to write this without that negative symbol, you can write it as a to the n. So in my example, n is 8. So let's be clear that n isn't negative 8. We have a negative here, we have a negative here. So where I wrote 8 right here, that's my n. So when I go to write the property, I'm going to say that you write it without the negative. It's going to be a to the n, but it moves to the denominator, and then there's a 1 left here. So if I just gave you this property, a to the minus n equals 1 over a to the n, and I gave you this problem, then you would be able to, let me start over and start with the property. You could think of the problem like this. So if a to the minus n is 1 over a to the n, and I give you some problem like 3 raised to the negative 8, and I tell you I want you to write this without the negative exponent, but of course we have to keep the value of the problem the same. You can't change the problem. So in this example, my a would be 3. Write that down. And in this example, n is 8. So, well, I can't draw the letter n. So if I wanted to use my property here, in fact, let me just replace a with 3 in both these positions, and let me replace n with 8 in both of these positions, and you'll see that you not only get the question, you get the answer. So replacing a with 3, and I'm going to replace this a with 3, and replacing n with 8, I'd have a minus 8, and then over here I'd have the n is the exponent on the a, and it was 8, so it would look like this. So literally just replacing my a with 3 and my n with 8. Replacing this a with 3 and that n with 8 gives me the question. It says 3 to the negative 8 power. And then replacing this a with 3 and this n with 8 gives me the answer to the question, 1 over 3 to the 8th power. So whatever you like better. I'm not sure the property really helps. It's just nice for you to see how we communicate mathematics using symbols. But if you wanted, you could do the same thing with, say, one of these down here. Suppose I want to take 10 to the minus 2 and write it without a negative exponent. If you wanted to use the property, you would say that the property is, in general, a to the minus n is 1 over a to the n. And since I want to do the problem 10 to the minus 2, and my job is to write the problem without a negative exponent, then the property would say that in your example, a here would be the number 10. So let's write that down. And the number n would be 2, not negative 2. See how the negative here matches the negative there. So my n value in my problem is just the 2. So replacing n with 2 in a second, you'll see the answers. N is 2. So I'm just going to literally just plug this in now and say the answer according to the property is 1 divided by my a is 10 and my n was 2. So the property does accomplish the problem, but most students just like to learn the rule. Look, if you have a negative exponent, write the answer without the negative exponent. There's a 10 here, and it's raised to the second. This is 10 to the second. The only difference is that the negative sign is no longer present. But if you're going to do that, and you want things to be mathematically correct, you need to move this to the denominator. And then if you want to simplify this, this would be 10 times 10, or 100. So by definition now, 10 to the negative 2 power is 1/100th.